Welcome to this EDUbrief. Are you new to IoT networks? I'm Gary Audin. There's no single class of IoT device. They come in all shapes and sizes. You design your network for workstations, data communications, voice over IP, and video. Now you have to embrace IoT, but there is no single form of IoT traffic to support. The traffic created by IoT devices varies considerably. The IoT traffic will also depend on whether or not an edge processor is used, how much intelligence it contains, and what applications are running in it. Edge processors can respond locally to sensors. Dumb devices require more interaction over the network with a data center or cloud service. Traffic characteristics include continuous traffic flow, which is streaming, polled endpoints to collect data, periodic data with automatic delivery. An IoT device may have actuators that require interactive communications. Passive devices do not contain actuators. They only report sensors data. Delay tolerance is the amount of time a data transfer takes to reach a destination. When IP networks transfer data, delays of hundreds of milliseconds are acceptable. When voice over IP and video over IP were introduced, 150 milliseconds was considered the upper delay acceptability. If you are dealing with measuring the emptiness of a fuel container like a propane or oil tank, this application can easily tolerate seconds of delay. If the endpoint is dealing with safety data or manufacturing systems, then 100 milliseconds may be too long. Data intensity is the amount of data created by a sensor. This can vary considerably. Very low bandwidth usage will occur when devices such as locks, doors, and light switches report their status. When edge processors are used, then large volumes of data may be transferred that covers what the processor application creates. Video high-definition cameras and some industrial machinery also fall into the high bandwidth requirement category. There's no shortage of technologies available for IoT networks. There are wireless and wired connections. Within the wireless world, you have the existing 4G and the emerging 5G cell services. Most IoT devices don't need high bandwidth of 5G networks. 5G is most attractive because of the number of IoT devices that can be supported. A different technology is called low power wide area networks. This is very good for covering areas which don't have cell service or in rural areas or where the cost may be excessive for the cell services. Wi-Fi is possible for small environments. Bluetooth is possible, but most likely will not be used because of the distance and bandwidth limitations. A new addition to 5G networks is called Citizens Band Radio Service. This is competitive to Wi-Fi and can offer longer distances and higher bandwidth. Citizens Band Radio Service is an emerging technology. There are not many products available yet, but expect them in the future. The only reason for mentioning satellite service is that there are places like the Rocky Mountain States, Alaska, and much of Canada that will not have any available wireless service other than satellite. The wired world has an interesting capability, which is operating power over Ethernet over twisted pair category 1, 2, and 3 cable. This requires either cable adapters or specifically designed local area network switches. This reduces the wiring requirements because you can use the existing telephone cables. This solution can operate over 1,000 to 2,000 feet of cable. Category 5 or higher Ethernet is also available, but remember that the cable distance limitation is 100 meters or 330 feet. In the case of video cameras and surveillance equipment, coaxial cable is a candidate. It can offer both high speed and long distance over several thousand feet. Fiber optic cable is possible, but likely to be too expensive for the large number of IoT endpoints that need to be connected. IoT devices are not monolithic. The demands on the network will be far more varied than what IP network designers have encountered in the past, including voice and video over IP. Bandwidth delivery will be difficult to manage, especially when there is a network congestion. One of the benefits expected with 5G networks is the ability to deliver very low delay. The low delay tolerant IoT devices may be best supported on 5G. IoT devices that can work with longer delays may be better suited for wired connections. Security is an issue because badly or improperly secured IoT devices are open to malicious attacks. Over 80% of global IoT transmissions are not encrypted. IoT data collection and its use produce privacy issues when the individuals who are observed by IoT devices have different privacy expectations. Network availability. Striving for 99.999% uptime becomes a high priority in the network design. The use of IoT endpoints further integrates the network into the success or failure of the organization. Deploying edge processors can offer sensor support even when the network connection fails. The wired connections can be automatically routed through wireless networks when the wired connection fails. Prioritizing traffic will be problematic. Voice and video traffic is usually given a higher priority than data traffic. Some IoT devices may demand higher priority transfers that will need higher quality of service than voice and video. Software-defined WANs and MPLS may be required for some of the IoT traffic, while more tolerant IoT traffic may be transferred with lower priorities. Thank you very much for viewing this EDUbrief.